Okay. Now, for multivariable versions, not only you can do limits, you can also do derivatives. If you recall in Calc 1, you learned to do limits because you had to do derivatives. So here's a Calc 1 version of derivatives. If you have a function, f of x, then the derivative was f prime of x is equal to limit h going to 0 of f of x plus h minus f of x over h. That was the derivative in Calc 1. Okay. Now, what do you do if you have x and y? Well, nothing different. You just, if you have x and y, then you just ignore one of them. Just carry on. You write the exact same thing, x plus h, but then there's this y attached. And divide by h, and you send h to 0. Now, you can see that what's happening is that I'm not changing anything in the y direction, but I'm only changing something in the x direction, right? And that means that this derivative is not really the full derivatives. You can't talk about full derivatives. What you can do is you can say, I'm differentiating in the direction of x. So instead of writing, the Leibniz notation for this is df over dx, right? That's the symbol for differentiation in Calc 1. But now the symbol for differentiation is this round thing. Sometimes it's pronounced round f over round x, or sometimes they just say partial f with respect to partial x. This thing is called the partial derivative of f. Now, of course, there's the version with partial derivative with y. In which case, x isn't doing anything, you're just subtracting. You're just changing the y values. Okay. Now, in practice, what this means is that you're completely ignoring y. That's what it means. It's like you're thinking about y as some extra constant that's tagged along with f. So here's what I mean in the actual situation. So let's say f of xy is equal to x squared plus 3xy plus y cubed. In this case, if I do partial of f with respect to partial of x, round f over round x, then it means, first, a priori, it means calculating this limit. Okay. And I don't want to go through all the calculation. It's just going to be horrible. You know how these things could be horrible, right? But if you did it, it will amount to the following thing. It's like considering y as constants, and you're just differentiating by x. So if you differentiate x squared, it's 2x. That's nothing surprising, right? If you differentiate 3xy, you're differentiating this by x, so it's 3y. And if you differentiate y cubed, you're considering y as a constant. Therefore, if you differentiate it by x, what would you get? 0. This is what you will get if you did this limit. Right? The same thing, if I do the partial of f with respect to y, this time you're treating x as the constant and y as the variable. So if you differentiate x squared by y, you get 0 because you're treating x as a constant. And if you differentiate 3x by y, you get just 3x because y differentiates to 1. Right? And then y cubed differentiates to 3y squared. That's it. That's what we call the partial derivative. Very simple. Right?